Today we're going to learn about two main branches of statistics and what comes up in those branches. The first of those is called descriptive statistics. And you'll notice in the picture they've got graphs and charts. That's the kind of stuff that comes up in descriptive statistics. The key thing about descriptive statistics is that it describes things. You've done descriptive statistics before, pretty much everybody has. You do things like finding averages in about fourth grade, that's descriptive statistics. Or if you do sports statistics, that's descriptive statistics. In descriptive statistics, you try and take the data you have and organize it in a meaningful way, make sense out of it. One of the key questions you look at is what's average? And like I say, you did that back in fourth grade when you'd add up numbers and divide by how many there are. You're also smart enough to know there's more than one kind of average, and later on we're going to be looking at a lot of the different averages that there are, including some you haven't done before. Another important topic that comes up in descriptive statistics is how spread out things are. You can look at whether things are packed really close together or whether they're spread out over a wide area. I could say, for instance, that over all the years I've taught classes at Garrigan, the average grade has probably been a B. Well, it would make a big difference whether that meant everybody got a B, or whether that meant there was a big wide spread, went from A to F, but most of the people ended up in the Bs. Well, you being smart students would probably hope that it's the second one so that you could get a good high A and other people could have lower grades that average you out. One other thing that we'll talk about with descriptive statistics is how one piece of data compares to everything else. I know that when we have a test in my classes, one of the things that people always do is they'll look around and compare their score to everybody else's. They want to know, did you do as well as your friends did, or did you do better than your friends did? A lot of times people will look at what I have written up on the front board and they want to see if their initials are there. Well, that's looking at how things compare to another thing. To this day, I can remember the very first test I took, God help me, 40 years ago at UNI when I was taking a calculus class there in the fall of 1980. And I got my first test back there. And it ended up, I believe, being 52 points out of 60. No, it was 60 points. I just don't remember for sure my score, but I know it was somewhere in the lower 50s. Now, in every test I'd pretty much taken in my life in math, I had always gotten A's. And so I looked at that and thought, geez, maybe it's time to change your major here. You aren't doing as well as you thought you could. Well, then I started looking around the room and seeing how everybody else did. And it turned out that my score was actually the second highest score in that class. And we found out later that John Bruja, who you guys will hear about later in the year when we get to calculus, he had the philosophy that an average student should get half of the possible points. And this is an average calculus student, and people in calculus are smart to begin with. But he felt the average student should get half of those points, so out of 60 points, average should be 30. There were people that scored in the teens that passed that test, and in the 50s was really very, very good. So the number itself doesn't necessarily mean nearly as much as how it compares to everything else. But again, descriptive statistics, you're describing how things are. The other key branch of statistics is inferential statistics. And inferential comes from the word infer. What we're going to do is not just describe things, but then go beyond there and say, okay, so now what? What we do in inferential statistics is we interpret data. You look at the data and you make generalizations and predictions based on what's going on. The idea of making generalizations and predictions, that's exactly what infer means. The most important thing we're going to do in inferring things is determining whether or not the results we have are significant. And I will tell you, significant is a really important term. In fact, it's just about the only word all year you're going to have to write out a definition of rather than having it as like matching. However, significant doesn't necessarily mean what people think it means. What significant means is that a result didn't happen by chance. It was unlikely to have happened by chance. Basically, if you did it again, you'd probably get the same result. However, significant doesn't necessarily mean that you have a result that's big or important or you have to pay attention to it. It just means it didn't happen by chance. We're going to look at 4 other terms today, and those are population, parameter, sample, and statistic. A population is just a big group that you want to find out about. Notice it does not have to be a group of people. You could have a population of deer, or Snap-on could have a population of toolboxes. You could have a population of potato chips. It's any big group that you want to find out about. That's your population. A parameter is just a piece of information about the population. I might, for example, want to find out the average height of every student at Garrigan. That would be a parameter because I want to know about every student. And information about everybody, that's the population, so it's a parameter. I could actually find that information if I wanted to. I could literally measure everybody or do a survey and ask everyone, how tall are you? But that would still be kind of a pain to do. And sometimes it can be very impractical or literally impossible to find out parameters. I used to show a different film where they looked inside the Frito-Lay factory and they were looking at the quality control that's done on potato chips. Well, it turns out if you do quality control on potato chips, what you do is you grind up those potato chips and you do chemical tests for things like the salt content. Well, when you do that, you've used up your potato chips, so you don't have any to sell. You couldn't do that to the whole population. It's just literally impossible to do that. There's also things like the US government often wants to find information about the people in our country. But in the time it takes them to do that, things change. You can have people that are born, people that die, people change jobs. There's lots of things that change just in the time it takes them to gather data, and that makes it very impractical to try and find that kind of parameter. So what we do instead is, instead of using the whole population, we'll take a sample. A sample is just a small group that represents the population. Maybe instead of asking everybody at Garrigan how tall they are, I'll go to each classroom and just ask a couple of people in each class how tall they are, and that's going to end up being my sample. Similarly, Frito-Lay doesn't look at every potato chip. What happens is every few minutes they'll take a bag off the line and run their tests on that bag. That's a sample that represents all the potato chips they produce. A statistic is just a piece of information about the sample, like the average height of the students I actually ask, or the salt content of the actual potato chips that they look at Frito-Lay. Information about the sample is a statistic. And what happens is we're going to use statistics to estimate parameters. We use information we find out about samples, and we use those to find out about the whole population. One quick way you can think about those is look at the letters they begin with. Population and parameter both begin with P. Sample and statistic both begin with S. So yeah, parameter is information about a whole population. Statistic is information about a sample.